Hi, everybody. So my name is Boris Litvinsky from Wix. Nice. And today I'd like to talk to you about why and how you should be involved in improving your IDEs. So I'd like to start by saying that JavaScript community is amazing, right? The amount of involvement and the amount of innovation that the community has shown throughout the years is bar none, right? We're a completely self-sustaining community. I mean, since I think 2009, we are in a nothing short of an industrial revolution, right? Just think of all the amazing things we as a community have built, right? We've built amazing frameworks that help us bypass the limitations of the language and allow us to build complex applications relatively quickly. We've built amazing tools, build tools that help us optimize our code. And we've even managed to convert our language into a true cross-platform language, which is amazing. So give yourself a round of applause. All of you are completely amazing. The problem is, however, that we're doing all these amazing innovations using Stone Age tools, right? Namely our IDEs. I mean, the IDEs used within the JavaScript ecosystem are light years behind anything, behind their counterparts in any other language, right? Let's see a proof. This is a pull request from the VS Code repository from May of 2018, right? And in May of 2018, moments before we're all moving to Mars, we finally got an amazing new feature that allows us to automatically rename variables. Okay? Really? 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 Is this the best we can do? This makes me really sad. And we're so used to using such primitive tools that we are ignoring the amount of time we're wasting on a daily basis on doing mundane manual labor, right? And let's see an example. Let's say I have this super simple React component that doesn't do much. And let's say I'd like to extract those two lines into a new component, right? Super simple. So how would I do that? Well, I'd create a new file, I'd import React, I'll declare a new component, and I'll copy over my 2 lines of JSX, right? And I'm done, but nah, not really, because now I need to remember to refactor my props, my state references to props, because I don't have state anymore. Oh, but I also need to remember to refactor my method references because I don't have these methods either. Oh, but I've also copied multiple lines of JSX, so now I need to remember to wrap everything with a fragment. It's a nightmare. It's simply a nightmare, right? When was the last time you've heard of a Java developer extracting a class manually, right? And we are doing these things dozens and dozens of times every day, right? And just think of how error-prone those things are. Now, don't get me wrong, right? The IDE vendors are amazing, right? They're going out of their way to constantly ship new features and improve our workflows. But let's be honest, right? They don't stand a chance in keeping up with us, right? They don't stand a chance in keeping up with the evolution of the JavaScript ecosystem. I mean, even if they were to shift all of their focus to JavaScript, right? Which they don't because they usually support multiple languages. Just think of all the supersets of the language, right? Just think of all the flavors. Just think of all the frameworks that we're using. Just think of React and the amount of features that they have shipped in a couple of months, right? It's crazy. And I think this is exactly where we all should come in, right? This is exactly where we need to show the same level of involvement that we have shown in other aspects of the ecosystem. And there is no reason for us not to do so. Because surprisingly to all of you, and to me as well, you already possess all the knowledge you need in order to get involved, right? This is the VS Code GitHub repository, and as you can see, it's written in the language you already know, right? And in order to showcase how powerful your involvement can be, I'd like to showcase an extension that I've built for VS Code that adds refactoring capabilities to your IDE, right? So let's go to a short demo. So let's say that I have a simple React component, and what I'd like to do is extract those two lines into a separate component, right? So what I do is basically I'd select my JSX, right? And let's say I'm immediately presented with two options that allow me to either extract a component into a new file or an existing one. So let's select a new one. Let's select the directory, and we can either select a new file or an existing one. Let's select a new one. Let's call our component a button. And that's it, right? I'm done. I have a brand new component that contains all my JSX with all the references rewired, React exported, and even the component itself exported. If I will go back, I can see that my new component has been imported, and I can see that all the props has been passed to me with all the original references. So next, let's say I'd like to convert the parent component into a functional component for some reason. So I'm immediately presented with another option that converts a class component into a functional component. So when I click that option, I have a warning here, hope you can see it, that basically states that I will lose all the state references and all the set state calls and the lifecycle methods for obvious reasons, because functional components don't support them. And once I do that, again, I have a brand new component with the state references changed to props and the non-lifecycle methods maintained. It also supports Typescript. So let's say I have some types here, right? Let's say I want to do the same action that I've shown you previously. And now my functional component is annotated with the type, with the props and state type annotations merged. So that's nice. But it's sort of a bummer, right? Because if I do have lifecycle methods and I do have set state calls, I'm losing plenty of code when I'm doing the transition. But luckily for us, React recently shipped a brand new feature called hooks. And if I would go and I go to the settings, right, as shown here, this is the configuration of the extension. And I would go to that class after I've activated hook support, and I would refactor my component, again shown with the same warning. Suddenly I get a different result, because now all the state references have been refactored to hooks. All the set state calls have been refactored to the state setters, and my component did mount and will mount and will unmount have been refactored into use effect, respectively. You can see a tear down method in here. So going back to the presentation. This is the list of all the capabilities that it provides you. You can also switch from functional back to class, wrap your code with conditionals, and so on. So next, I'd like us to build an extension of our own, right? I'd like to show you how you can do the same. Now, I'm sure your wish list of the capabilities you would like your IDE to support is pretty big, and I'm pretty sure it will grow even larger. But today I would like to show an example of building an extension for VS Code. Namely, we will see basically which one it will be. So I told you that you already possess the knowledge required to do so, right? So a VS Code extension is nothing more than a node module, right? Written in JavaScript. And in order to get us started, we will use a generator provided to us by folks at Microsoft, which is exactly like what you would use to start your Angular project, the Angular CLI or React Create app. It basically generates a node module with all the dependencies and dev dependencies in place. You already have a testing framework there. You already have the debugging capabilities, and basically you're off to the races. So let's start the development. So first, what we need to do, we need to go to the package.json file of our extension and define something called an activation event. So basically, contrary to common belief, whenever you launch your IDE, it will not load your extension code immediately, right? Instead, it will do it lazily after one of the relevant activation events are fired, right? So for example, I can say that I want my extension launched whenever a user looks at a Typescript file, okay? Next, again, in the package JSON or in JavaScript, I can define something called a contribution point. Now, a contribution point basically states to the IDE environment which parts of the IDE will my extension be extending, right? And this can be anything, right? In that regard, the capabilities are endless. I can add a new panel. I can modify an existing panel. And on and on. In this case, what I'd like to do is I'd like to extend the IDE's configuration panel, adding configuration options for my extensions, right? Like we've seen earlier when I activated the hooks feature. And finally, in order to for our extension code to actually interact with the IDE, we are provided with the VS Code JavaScript Sdk, which is basically used for our code to call the IDE itself. So now the question is, what will our extension be doing, right? What capabilities will we be adding? In our case, we will implement a friction of the capabilities that Glean gives you, which is basically we will implement a class to function component refactoring, a simplified version of it. So basically, as I already said, our extension is just a node module. Which is being run whenever an activation event occurs. Now, whenever that happens, VS Code will call a single function that our node module exports. And this is basically, you can think of it as our main function, and this is basically where all of our JavaScript will be written. We will start by using the VS Code node module, right, to extract the configuration for our extension, right? In this case, I will extract the same list, a list of files that I want to treat as JavaScript, right? It's configurable since we added it in a contribution point. Next, I will register something called a code action provider, which is basically a class responsible for adding options to the code actions menu, right? Where basically this is the menu that the user sees and can select the refactoring he wants to launch. And this happens whenever the condition passed as a first argument is true. In our case, basically, we want the IDE to call our code action provider only in case a user is looking at one of the files the user has configured. And finally, we will add a listener for the actual code action, right? Whenever a user clicks, this is the function that will be called, right? So now let's have a closer look at the code action provider. So the code action provider is a simple JavaScript class that optionally implements an interface, again, provided to us by VS Code library, if you're using TypeScript. And it basically has a single method that basically returns a list of options we would like to add to the code actions menu. Each command, right, each option has a unique identifier and a human readable label. It's important to note that since this is a function, it can be done conditionally, right? You can modify the list based on some parameter. So now let's actually implement the refactoring itself, right? So if you remember, it all starts by the user basically selecting the code he would like to refactor, which means that the first step we need to do is basically get the selected text. So again, we will be using the VS Code API, and we will first get the selection range, right? The column and the line, the columns and the lines the user has selected, and we would then extract the text located within that range. Then we would perform the code manipulation itself. We will talk about it later. And finally, we will persist our changes to disk, right? Now, our extension is a node module, and all the extensions within VS Code run in a node process, which begs the question of why should I do the file manipulations and the persistence using the VS Code API and not, let's say, Node's native module, such as FS. Now, there are several reasons. First of all, it's just way more convenient, right? I have several convenience methods, such as replace and append, which make our work easier. The second reason being that you can basically batch the file changes, right? You don't have to change a single file every time. You can basically batch the list of files and the changes you would like to do to them and basically apply them as a transaction. You apply them together. And the last reason being that it can cause you weird bugs. So for example, imagine a situation where you have modified the code within the IDE, but you haven't saved it yet. And then you go ahead and you use an FS module, right, and modify the file system. So now what happens is that whenever you will try to save the file within the IDE, it will tell you that now you have a conflict, because now you have unsaved, on one hand you have unsaved changes within the IDE, on the other hand you have up-to-date content of the file on the disk. So this basically makes sure that all of them, the IDE and the file system, are in sync. So this basically concludes all the code that is responsible for interacting with the IDE, right? This also means that this is the last part that has to do with VS Code altogether, right? So now, when we will actually talk about the code manipulation, the techniques you will see can be used to implement it for whichever IDE you want, for any IDE you're choosing. So, how will we implement the code modification itself, right? Now, the obvious choice here, that you can think of, is maybe we will use some sort of string manipulation, right, and regular expressions. But this is not really scalable, right? You have lots of edge cases that you need to cover. So I promised you that you already have all the knowledge you need in order to implement such extension. So we will be using a tool you are all familiar with. which is Babel, right? Now, you probably are using Babel to transpile your code from ES6 to ES5, which is sort of like a transformation. But a little known fact is that Babel itself is comprised of smaller node modules, right? Babel is written in JavaScript as well, that it uses to perform its tasks. And those node modules can be used in a standalone manner. Now, another issue here is that I've shown you that our extension supports Typescript. And Babel is known as a thing that transpiles and transforms JavaScript. But luckily for us, since version 7, Babel supports TypeScript as well, like it understands types, which also means all the smaller node modules also support it, which is really convenient. So in order to understand how can we implement our transformation, we first need to understand how Babel does its magic, right? We'll learn from the best. So we will look at an example of the transformation of ES6 to ES5, which is usually what you use Babel for. So it all starts with the code string, right? The code you have just written, which Babel then transforms into something called an AST, which stands for Abstract Syntax Tree. Now, we will not go too deeply into what AST is, but you can think of it this way. An AST for JavaScript is what DOM is for HTML. Okay? It's basically a JavaScript object which describes your JavaScript. It has nodes. Each node has an API, which you can use to modify and to extract information for. So once we have that, we can actually do our manipulation. Again, same as we would with DOM, right? And once we are done doing all the transformation we need, we will transform the AST back to code. Okay? So now, let's see which node modules Babel uses in order to basically perform all those tasks. So the transition between the code and AST is done by one of these two packages. We will be mostly talking about the first one, called Babel Parser, which does exactly that, right? It takes a string and returns an AST, a JavaScript object that describes the code. Babel template is just a utility, is a nice utility library, which basically allows you to take a code string with placeholders and then replace those placeholders with AST nodes and get an AST back. Very convenient. So once Babel Parser basically gave us the AST, we will transform it. But if you will look at the typical AST, it's a pretty big object. And looking and traversing it can be a real pain, right? It's really, really, really inconvenient and inefficient. Now, in order to help us with that, Babel has a nice library called Babel Traverse, which basically allows us to pass an object which states an object with functions that basically states which types of nodes within the AST are we interested in, right? For example, I can say, look, I'm only interested in variable declarations, okay? And whenever that happens, basically a callback we have provided will be called with the node that represents the thing we're interested in. The problem is that similarly to DOM, the API provided for each node is pretty crappy. What helps here is a library called Babel Types, which is sort of like a jQuery Lodash type of library, which has plenty of methods and utilities that allow you to create new nodes, to alter existing ones, and so on. So once we are done doing all the transformations, we will then use a package called Babel Core, which allows us to basically convert the modified AST into code. So now that we have all the knowledge, let's see how we can apply it in order to actually implement our refactoring, right? So this is an awesome tool called AST Explorer, which really visualizes the whole aspect of working with ASTs. And what you see there is the code we would like to refactor, right? So next, we will use Babel Parser, which basically will convert the code into an AST. Okay, this is the actual AST representation of the code you see there. And this is where we get to the actual transformation, to the actual refactoring phase. So as I stated earlier, basically we will call Babel Traverse, and we will state which types of nodes are we interested in. In our case, we're interested in class declarations, right? Because we are transforming class component into a functional component. So once that happens and the traversal algorithm basically meets a class declaration, it will call our object and pass the node, okay, the actual class declaration. And then we can use the API in order to extract things like the class name, right? Because we need it in order to maintain the name once the function is constructed. So next, we will go traverse the class body in order to find the render function, right? Because we need to extract the JSX returned from it. Okay, so we will use the T dot there is a reference to Babel types, and we will use it in order to identify class methods. Okay, and then we will basically go looking for a function with the render name. So once we have that, we will traverse its body in order to find a return statement, right? Because the return statement is what actually contains the desired JSX we want to extract. We want to basically, yes, we want to extract into a function component. Finally, we will construct a function body, again using Babel types, which is basically the thing that is between the two parentheses within the function. And we will define its body as the original return statement, which contains the JSX we need. Finally, we will replace the class with the functional declaration, which we will construct using Babel types, passing it the original name and the body that contains the JSX, right? So now, basically, the end result here is that we have an AST of the functional component that we have constructed. So the final phase here is that we need to convert it back to code, right? So this is where we will apply Babel core, which will convert it back into a functional component. And we are done, right? Within less than 20 minutes, I think, we have added a pretty powerful capability into our IDE, okay? With the knowledge you already possess. So that's pretty awesome. So while researching for this talk, I've stumbled upon this question on Quora where someone asked, why should he even be using the IDE? So I like this answer. However, I think that if the IDE is our calculator, we should not be ignoring the fact that this is the calculator we currently have. We should also should not be trying to cover that fact with applying cool themes in order to make it look cool. Okay? Because today we've seen that we have knowledge to do way more with our IDEs. Okay? But I think that as much as this statement is profound, I think that it doesn't do enough justice. Remember that I told you that we are in the middle of an industrial revolution within the JavaScript ecosystem. And if that's the case, I think our IDEs are this thing, which is a steam engine, which was one of the inventions that kickstarted the industrial revolution, and it served as one of the main components in all the inventions that were created within that era. And I think that if we will treat our IDEs with the same respect, it will do the same for us. So these are several resources to get you started. And that's it. Thank you, guys.